Beneath the city of Naples, something is moving, slowly, steadily, for nearly 20 years. And now, scientists monitoring one of the most dangerous volcanic systems on Earth say the ground itself has risen to a level not seen since the last time this supervolcano actually erupted 500 years ago. 500,000 people live directly on top of it. And the warning signs, according to the researchers watching it closest, are impossible to ignore. This is the story of Campi Flegrei. If stories about the planet's most dangerous natural forces fascinate you, hit subscribe now, because we break down exactly what's happening at Earth's most closely watched volcanic systems every single week. Let's start with what Campi Flegrei actually is, because it isn't a mountain like most people. Picture when they think of a volcano, there's no single peak, no classic cone shape rising into the sky. Campi Flegrei is a caldera, a vast sunken depression stretching roughly 12 by 15 kilometers, half submerged beneath the Gulf of Pozzuoli, just west of Naples. It formed from two catastrophic eruptions in the ancient past, one of them nearly 40,000 years ago, considered one of the largest explosive eruptions in European history, ejecting well over 100 cubic kilometers of magma and covering an area the size of an entire country in volcanic ash. Unlike a single visible mountain, this kind of volcano hides in plain sight. Neighborhoods, roads, and even parts of Naples itself sit directly on top of the caldera. And right now, roughly 500,000 people live inside or immediately next to a zone that Italian authorities have officially designated for evacuation if the situation escalates. Here's where this story gets genuinely alarming. Like this video right now, if you didn't realize an active supervolcano sits underneath one of Italy's biggest cities. The only confirmed eruption in recorded history at Campi Flegrei happened in 1538. Over the course of just 8 days, a brand new mountain, now called Monte Nuovo, rose out of flat ground near the town of Pozzuoli, reaching a height of over 130 meters. It remains the first new land ever formed on mainland Italy in recorded history. Roughly 24 people died. And in the decades leading up to that eruption, historical accounts describe something eerily familiar to what scientists are recording today: a slow, persistent rise of the ground, accompanied by increasingly intense earthquakes that nobody at the time understood the meaning of. Now, fast forward to today. Since 2005, Campi Flegrei has entered what scientists call a phase of accelerating unrest. The ground has been rising at a rate of roughly 1 centimeter per month, and the cumulative uplift since that period began now exceeds 140 centimeters, more than 4.5 feet of vertical rise recorded at the surface. To put that into perspective, that's more ground movement than was recorded during 2 entire unrest episodes in the 20th century combined, in the 1970s and 1980s, both of which triggered public panic and partial evacuations at the time. Don't forget to subscribe before we get into what scientists are saying about where this trend might be heading, because the numbers involved are hard to ignore. Alongside the rising ground, earthquakes have become a near constant presence in the region. In recent months, researchers recorded dozens of tremors every single week. And in June of 2025, the area experienced its strongest earthquake in decades, a magnitude 4.6 event that was felt across Naples and caused structural damage to buildings. It was, according to monitoring records, the most powerful seismic event associated with this current unrest cycle since it began nearly 20 years ago. Then, in May of 2026, another swarm struck, including a shallow magnitude 4.4 earthquake that rattled the Gulf of Pozzuoli and triggered a fresh cluster of aftershocks within hours. Scientists studying the seismic data have also gained a clearer picture of exactly where these earthquakes are originating. Using machine learning models to reanalyze tens of thousands of tremors recorded since 2022, researchers found that seismic activity has sharply increased specifically in shallow zones beneath heavily populated urban areas along the edge of the caldera. In other words, the earthquakes aren't just increasing in number, they're increasingly concentrated in exactly the areas where people live. Here's the part that has researchers most concerned, and it's worth pausing on. Make sure you're subscribed, because this next detail is the reason headlines about this volcano keep resurfacing. Earlier this year, a team of researchers published a study analyzing the mechanical stress building up within the rock beneath Campi Flegrei. Their conclusion was striking. Based on current trends, they project the system could reach what they describe as a critical mechanical transition sometime within the next decade, potentially between 2030 and 2034. That doesn't necessarily mean an eruption is guaranteed. The researchers themselves are careful to stress that point. But it does mean the crust beneath the region is approaching a threshold of stress it hasn't approached in centuries, a threshold tied to the same kind of underground pressure that historical records associate with the lead up to the 1538 eruption. Separately, thermal modeling conducted by other research teams estimates that a pressurized reservoir of potentially eruptible magma currently sits at a depth of roughly 4 kilometers beneath the caldera, That's shallow enough, researchers say, to be directly relevant to how the system might behave if unrest continues to intensify. None of this means an eruption is imminent. Italy's Civil Protection Department currently maintains what's called a yellow alert, officially defined as a level of attention, rather the ER than emergency. And volcanologists monitoring the area consistently emphasize that periods of unrest like this have occurred before without leading to an eruption, including cycles in the 1950s, 1970s, and 1980s that eventually settled back down. But several scientists studying the current data now describe this phase as different from those earlier episodes, both in how long it has lasted and in how much cumulative ground. Deformation has built up without any sign of the system returning to a stable baseline. This phenomenon of the ground rising and falling over time even has its own scientific name, Bradyseism, derived from Greek words roughly meaning slow movement. It's one of the defining characteristics of Campi Flegrei, and it's been documented for centuries, visible even in ancient Roman ruins nearby, where columns show clear evidence of having been partially submerged underwater during past periods of ground subsidence, then re-exposed as the land rose again. So what would actually happen if this unrest eventually did culminate in an eruption? Potential say that, based on the geological record, any new eruption would most likely be moderate in scale compared to the caldera's moderate. In this context, is a relative term. Researchers say a new eruption could still produce ejected volcanic blocks near newly formed vents, pyroclastic flows extending several kilometers, an extensive ashfall capable of affecting large parts of Naples itself, a city home to roughly 3 million people in its wider metropolitan area. That's precisely why Italian authorities maintain a detailed evacuation plan covering the highest risk zones, an area collectively home to around 500,000 residents. It's also why scientists continue to push for constant, uninterrupted monitoring of the region, using seismic sensors, gas analysis, ground deformation satellites, and thermal imaging to track even the smallest changes in the system's behavior. What makes this story so unsettling to many researchers isn't necessarily the size of the earthquakes or the pace of the uplift on any single day. It's the trajectory. Nearly 20 uninterrupted years of accelerating unrest with no clear sign of the system settling back down the way it did in previous decades. Ground still rising, earthquakes still increasing in both frequency and shallow concentration beneath populated areas, gas emissions still elevated, every measurable signal pointing in the same direction, even as scientists are careful to stress that direction alone doesn't guarantee where this ultimately ends. For now, life in Naples and the surrounding Campi Flegrei region continues largely as normal. Most residents feel only a small fraction of the tens of thousands of earthquakes recorded in recent years, the vast majority far too weak to notice. But underground, the pressure, quite literally, continues to build, and the scientists watching it most closely say the current phase of unrest has now pushed the system further than at any point since the ground last cracked open in 1538. Whether that pressure eventually finds its way to the surface, or gradually settles back K into another quiet period like it has before, remains one of the most closely watched open questions in volcanology today. Let's dig a little deeper into just how enormous this volcanic system really is, because the scale of it is easy to underestimate when you're not standing directly on top of it. The two ancient eruptions that created this caldera weren't ordinary volcanic events. The larger of the two, sometimes called the Campanian ignimbrite eruption, is considered one of the most powerful explosive eruptions to occur in Europe in the last 100,000 years. Ash from that single event has been detected in ice cores as far away as Greenland, and in sediment layers across the Mediterranean and even into parts of Russia, a testament to just how violently the material was thrown into the atmosphere. Compared to that ancient catastrophe, the 1538 eruption that formed Monte Nuovo was tiny. But even a small eruption from a caldera this size, sitting directly beneath a modern metropolitan region, carries enormous consequences simply because of how many people now live there. Naples wasn't a major city in 1538. Today, it's one of the most densely populated urban areas in southern Europe, which is precisely why volcanologists treat even a moderate eruption scenario with such seriousness. It's also worth understanding how scientists actually track a volcano like this, since you volcano building toward an eruption. Researchers rely on a combination of tools working together. GPS stations and satellite radar measure ground deformation down to the millimeter, tracking exactly how much the surface rises or falls and where. Seismometers scattered across the region detect and locate even tiny earthquakes far too small for people to feel. Gas sensors positioned at fumarole sites like Sulfide and Pisciarelli continuously sample the chemical composition of gases escaping from underground, watching for shifts that might indicate magma moving closer to the surface. And thermal cameras monitor surface temperatures at these same vent sites, watching for sudden spikes that could signal changing conditions below. Taken together, these instruments allow scientists at Italy's Osservatorio Vesuviano, the volcanological observatory responsible for monitoring the region, to build a detailed, constantly updating picture of what's happening far beneath the surface, even though nobody can directly see or access the magma and fluids driving all this activity. One of the more remarkable pieces of evidence scientists point to when discussing this volcano's history isn't even underground. It's visible in the ruins of an ancient Roman marketplace called the Macellum of Pozzuoli, sometimes referred to as the Temple of Serapis. Marble columns still standing at the site show unmistakable bands of damage from marine organisms, clear evidence that the columns were once submerged well below sea level for an extended period, only to be lifted back above the waterline as the ground rose again over the centuries. It's a striking physical record of just how dramatically this landscape has moved up and down over time, long before modern instruments existed to measure it precisely. Scientists studying the current unrest phase have also tried to answer a difficult question. Why has this particular episode, beginning in 2005, lasted so much longer and produced so much more cumulative uplift than the shorter crises recorded in the 20th century? One leading theory points to an increasing magmatic component within the fluids driving the unrest. Earlier unrest episodes are generally believed to have been driven primarily by hydrothermal fluids, essentially superheated water and steam moving through cracks in the rock. But geochemical analysis of gases released during the current phase suggests a growing contribution from actual magma degassing at depth, which would help explain why this cycle has proven more persistent and, in the eyes of many researchers, more concerning than previous ones. That distinction matters enormously to volcanologists because a system being pressurized primarily by water and steam behaves very differently from one where magma itself is playing an increasingly active role. It's part of why researchers have shifted the language they use to describe this unrest, moving from routine monitoring updates toward increasingly detailed scenario planning for what different levels of escalation might actually look like on the ground. It's worth comparing Campi Flegrei briefly to the volcano most people already know sits nearby, because the contrast says a lot about why this particular system worries scientists so much. Mount Vesuvius, visible across the bay from Naples, is world famous for burying Pompeii in the year 79. It's a classic cone-shaped stratovolcano, the kind most people picture when they imagine an eruption, and it remains closely monitored in its own right. But Vesuvius, for all its notoriety, is a single, well-defined structure. Scientists know roughly where its magma sits and roughly how it tends to behave. Campi Flegrei is a different kind of threat altogether. Because it's a caldera rather than a single peak, an eruption could, theoretically, break out from any number of points across a wide area, rather than from one predictable summit. That unpredictability is part of what makes calderas, as a category of volcano, uniquely difficult for scientists to forecast. It's the same broad category of volcano that includes Yellowstone in the United States, another heavily monitored system known for slow, large-scale ground movement rather than a single obvious peak building toward an eruption. That comparison isn't meant to suggest Campi Flegrei matches Yellowstone's largest ancient eruptions, which rank among the most powerful volcanic events in the planet's history. But it explains why volcanologists study caldera systems using such a wide, overlapping network of instruments, rather than watching a single summit for smoke or lava. With a caldera, the entire surface has to be treated as a potential warning zone. There's also an economic and cultural dimension to this story that rarely makes it into scientific papers. The Campi Flegrei area isn't just a hazard zone. It's one of the most historically rich regions in Italy, filled with ancient Roman ruins, ports, temples, and coastal towns that have drawn visitors for centuries. Pozzuoli itself was a major port city in the Roman era, and the surrounding coastline includes archaeological sites that predate Pompeii. Balancing the historical and tourism value of the region against the volcanic risk it sits on is an ongoing challenge for local authorities, one that grows more complicated every year. Unrest continues. Local governments have spent years developing detailed evacuation logistics because of this tension. Moving hundreds of thousands of residents out of a densely built, historically significant urban area isn't something that can be improvised mid-crisis. Officials have mapped road capacity, transportation routes, and staging areas years in advance, precisely because the geology of the region makes it impossible to guarantee how much warning time residents would have if unrest ever escalated toward an eruption. That's part of why scientists emphasize communication as much as raw data. Public trust in monitoring agencies matters enormously in a region where evacuation plans depend on residents believing and acting on official guidance when it's issued. Researchers have noted that after decades of unrest cycles that never resulted in an eruption, some residents have grown somewhat desensitized to alerts, a pattern that concerns emergency planners even more than the seismic data itself. Meanwhile, the scientific community continues refining its models. The 2026 study projecting a possible critical transition within the next decade isn't the final word on the E subject. It's one contribution to an evolving body of research, and scientists have been clear that future observations could shift a hat timeline in either direction. Some remain cautious about a fixed timeline at all, noting that volcanic systems like this one have defied simple predictions before. What nobody disputes, however, is the raw data itself. The ground has risen, the earthquakes have increased, the gas emissions remain elevated. Those are measurable facts, tracked by some of the most sophisticated volcanic monitoring infrastructure in the world, and they form the foundation for every scenario scientists are currently studying. So where does that leave the roughly 3 million people living in and around Naples today? Largely, it leaves them exactly where they've been for the better part of 2 decades, living alongside a slowly evolving natural process that could settle back down, the way it has multiple times before, or could eventually culminate in the kind of eruption this region hasn't experienced in nearly 500 years. Scientists don't have a definitive answer yet. What they do have is an unprecedented amount of data and an unprecedented level of attention focused on a volcanic system that, for centuries, sat mostly outside the public consciousness. That's arguably the most important part of this entire story. Campi Flegrei isn't a sudden crisis that appeared out of nowhere. It's a slow, patient, decades-long unfolding of geological pressure playing out in real time beneath one of Europe's most historic and densely populated regions, watched more closely today than at any previous point in its long, restless history. If this story gave you a new appreciation for just how much is happening beneath our feet, make sure you're subscribed because there are more deep dives like this coming every week. Hit like, drop a comment, letting me know what natural phenomenon you want covered next, and I'll see you in the next video.